Hey guys, it's Mr. Myers. I'm not feeling so well, so here's some notes on how to solve rational equations. I'm going to show you how to do it algebraically and with a calculator. Alright, so here we have our solving rational equations notes. You guys have the same paper but in green. And notice that this says you already know how to solve these, so you're going to try a few. X over 3 equals 9 over 5. How do you go about solving this? What's the method that we're going to use? Cross multiplication, the thing that so many of you guys love and often call the butterfly method, which I hate. So let's try it. We can see why it's called the butterfly here. 5 times x is 5x, and we set that equal to 9 times 3. Solving, we get x equals 27 over 5. Now, why does this method work is a pretty loaded question. But for now, we'll stick with that it eliminates the denominators. Go ahead and give this next one a try on your own. All right, hopefully we got that x is equal to 21 over 2 after simplifying. And that came from 4 times x is 4x and 6 times 7 is 42, and then solving. So what if we have a binomial in the denominator? Let's investigate that. Can we still just use cross multiplication? So this would be 15 times x plus 8. And we would set it equal to 30 times x minus 2. Distribute the 15 and distribute the 30. 15x plus 120 is equal to 30x minus 60. And let's get our x values on one side of the equation and our constants on the other. Just to keep my x's positive, I'm going to subtract 15x from each side. And I'm going to add this 60 to get rid of that on that side. So I have 180 is equal to 15x. Dividing both sides by 15, I get that x is equal to 12. So yes, this method still works. If you were to plug a 12 back in for these x's, I guarantee you that this side would equal this side. All right, so here's the point of it all. When you use cross multiplication, you're really multiplying both sides by the LCD. And unlike what this paper says, anytime that you just have a fraction set equal to another fraction with nothing else like being added or subtracted, like you can see down here that we have a plus sign in the middle of these. But if it's just a fraction set equal to a fraction, I want you to work them the exact same way that we just did up here. However, these steps will always work. To solve a rational equation, state any domain restrictions that would make denominators equal 0. It's because we cannot divide by 0. Whenever we divide by 0, we get an asymptote. So what number could I plug in here for x to make this denominator 0? Well, negative 3. So I know that a restriction is that x cannot equal negative 3. In the same way here, if I plug a 4 into this, I'll get 4 minus 4 is 0. So x cannot equal 4 either. That's a little comma. You can always just set the denominator equal to 0 and solve. That's another way of getting these numbers. Now, to find this LCD, we do that the same way. Like, imagine that there was a plus sign in between here, right? What does this denominator have that this one doesn't? And what does this one have that this one doesn't? Well, we ended up getting that our least common denominator is whenever we just multiply those things by each other. So x plus 3 times x minus 4 would be the LCD. And normally that'll come in handy because that's how we're going to clear the fractions, is by multiplying every term by the LCD. But because we just have a fraction set equal to a fraction, we're just going to use cross multiplication to solve. All right, so let's set this up together. 4 times x minus 4 equals 7 times x plus 3. Remember to distribute the 4, distribute the 7. So you have 4x minus 16 equals 7x plus 21. get things on, well, let's move this 4x over to get 3x, and I'll subtract 21 from each side to get negative 37. And so I get x is equal to negative 37 over 3. All right, so now in this example, things start changing, right? We have this plus sign here, so I can't just use cross multiplication. Now, let's set up our restrictions first. What would cause us to divide by 0? Well, this 3 is always going to be a 3, so we don't have to worry about that. But if x equaled 0, I would be dividing by 0. So x cannot equal 0. Now let's come up with our least common denominator. So I'm looking, I see that this one has an x and this one has an x. So they're the same, but this one has a 3. So to make them all a common denominator, the LCD would have to be 3x. Now the directions above say, now to clear the fractions by multiplying every term by the LCD. So I'm going to zoom in here, and I'm going to multiply every single one of these terms by the LCD, by 3x. And this is what's awesome. Whenever you multiply by the LCD, you cancel out the denominator. See, there the x's cancel. Here again the x's cancel. And in this middle term, this 3 and 3 cancel. So what I'm left with is 3 times 1, which is 3, plus 13 times x, or 13x, is equal to 7 times 3, which is 21. So I have 13x is equal to 18, leaving me with a final answer of x is equal to 18 over 13. So to reiterate, the biggest trick is to multiply every single term by the LCD, and all your denominators will go away. All right, let's try another one. Here we have x minus 3 in the denominator. So what is my restriction? Then x cannot equal positive 3, because 3 minus 3 is 0. What's the LCD? Hopefully we got that it's 3 times x minus 3. So now take each one of these and multiply by the LCD. We've got each one of these set up to multiply by the LCD. Now let's do our canceling. X minus 3 cancels x minus 3. This 3 cancels this 3. And over here, nothing gets canceled because there was no denominator. So 3 times x is 3x. 1 times x minus 3 is just x minus 3. And 3 times x minus 3 is 3x minus 9. From here, we can just solve. Since these are on opposite sides of the equation, this 3x and this 3x, they're going to end up canceling each other. So we get x minus 3 equals negative 9. Add 3 to each side, and x equals negative 6. Now, I haven't really pointed it out yet, but before I can circle this answer, I need to go make sure it's not in the restrictions. So this is not in the restrictions, so x equals negative 6 is a fine answer. All right, now I know what you're thinking. I don't like doing this at all. So now I'm going to show you how we can also use a calculator to do it. But it's not always the best option. Remember, on the front of this page, we got answers that were like negative 37 over 3 and 18 over 13. Those aren't very easy numbers to see. But I'm going to show you how to do number 4 using the calculator. First of all, let's state our restrictions. What would cause me to divide by 0 here? X cannot equal negative 2. And what's the LCD? Well, the only denominators are x plus 2, so that's the entire LCD, x plus 2. But instead of going through and multiplying each one of these by the LCD, I'm going to show you how to do it in the calculator. What we want to do is put this entire side into y1 and this side into y2. And make sure that you're using alpha y equals, so that way we get good fractions. That way our table is also in fractions. All right, so here you can see I've got this typed into y1, this typed into y2. So now if I were to graph this, the answer to this problem is the x value where these things intersect. And here we can see that there's a clear intersection. So I'm going to second trace, intersect. First curve, I'm going to get close to this intersection. First curve, hit enter. And second curve, see how it jumped to the other curve? Hit enter. Hit enter for guess again. We get x equals 4. And we should be able to verify that with a table. And so here you can see at x equals 4, you get the same y values. You also want to check and see if there are multiple solutions. But at no point are we actually getting the same y values. Here you can see that there's an error. And the error actually means that we hit that restriction, -2. Earlier we said x cannot equal -2. Alright, so the answer here was x equals 4. Alright, so now you can take this crazy one right here, see if you can state the restrictions in the LCD, and find the value using a calculator. And just a hint, you might want to factor this first. Just to make sure that we're off to a good start, we should see that the restrictions are that x cannot equal -2 or -3, and that the LCD is just x plus 2 times x plus 3. And then once I'm looking at the graph, I'm not seeing any super clear intersections. I mean, there might be one over here, so go to your table and check. Look for the y values that are the same. So let's keep going into the positives. And here we go. At 7, we get 7/10 and 7/10. And then go ahead and check a few other ones. We can't find any. So we're going to settle with x equals 7. And I'll show you how to do this more algebraically whenever I get back and I'm not sick anymore. Okay, bye.